when 26/11 disaster had happened, and we have lost our many soldiers' life. So our target was that how we can save them. We thought that let's take our all that education and knowledge which we have gained from our college and institute, and apply that all and take, obtain a final solution which can save our soldiers life. So we have designed a combat unmanned guided vehicle. This vehicle can fire weapon, fire a rifle, and for its self defense it can fire a pistol, and also it can defuse a bomb. And for running on the ground it can be driven on any terrain surface. Also it can overcome the obstacle of height 20 centimeter. Also you can see here the rocker bogie mechanism. This how it works, that if any obstacle come in front side, first wheel which is in the touch with the obstacle will be pushed by other two wheels in the front direction, so it will overcome the obstacle, and this wheel which has overcome will pull the bot, and the last two will push the bot. So now the second pair of wheels will overcome the obstacle, and now whole front rocker four wheels will pull the bot in the forward direction, so last two will overcome the obstacles. And the mechanism for rifle reloading and triggering is the pneumatic system. This pneumatic system is controlled by the Raspberry Pi, which is used in the main master microcontroller. And this Raspberry Pi sends the signal to the transistor which controls the flow of air of the DCV. The DCV supplies the air to the pneumatic cylinder, and pneumatic cylinder reload the rifle. Now we are going to see the reloading of the rifle and triggering of the rifle. The pneumatic cylinder actuated and the rifle and pistol reloaded and triggered. Same way the movement of the rifle is controlled by the servo motors. This servo motor moves the rifle in 2 degrees of freedom, which face the front area of the robot. And same way the pistol is used for the back side. This pistol is for the self defense of the bot if anybody attacks it from the back side. This pistol also work on the same servo motors which move it in 2 degrees of freedom movement. For reloading of pistol and triggering of pistol, same pneumatic system is used, and the pneumatic system is filled, the air is filled for the pneumatic system by the compressor which is on board. We have onboard compressor. This onboard compressor fill up the air in the reservoir, and reservoir supply air to the weapons. For the bomb defusal, we have 4 robotic arms. These 4 robotic arms have the 2 grippers. The gripper is used for holding wires and holding packaging. Plus we have a cutter robotic arm having a cutter mounted as an end effector. This cutter will cut out the package and cut out the wires. We have a drill as a 4th robotic arm. This drill will when we have a liquid type bomb, this drill will have the hole in the package, and it will drain out all the liquid charge, so when the bomb triggers, bomb will not blast. We have a third camera. This third camera also have a 2 degree of freedom movement. This will give the live feed from the bomb diffuser unit plus from the ground, and these whole 3 feeds will be supplied to the GUI, graphical user interface, prepared by us. This graphical user interface will give two cameras feed at a time, and when we are attacking or bomb defusing, we can select the cameras. Why we are having only 2 camera feed is because the Raspberry Pi only gives the live feed of 2 cameras, and we can select the third camera when we are not attacking with the rifle. We can go to the bomb defusal camera, and this whole bot is controlled by a GUI with the help of a Wi-Fi. We have applied the whole mechatronics concept on this bot, and as you have seen that whole mechanical, electronics and programming concepts have been applied on this bot. So we are clear with the practical point of view, and also we have learned some power management concepts, and the main thing is the teamwork which we have learned that with how to work in tandem with our team with different departments of electronic, computer control and mechanical. In main designing phase, we have to prepare a best design which can be fabricated easily and which can be user convenience. So which we have learned that as we are the user in this project, so after designing, we have learned that we have to first think of the user convenience, we have to first think of the easy fabrication, and we have to first think of the robust and best concrete design. And in the fabrication process, what we have learned is the fabrication process should be not not a small things should be tolerated, not a small allowance should be tolerated, because when it comes to the user part, it will create some impact, and it will create the working, it will fail the working in which manner the designer had been designed. So as per the designer fabrication and as per the user convenience, we have learned that all the three concept, all the three departments should be kept in mind while the designing, while fabrication, and while the user part. The thing which we are not knowing before was that the first thing was the rocker bogie mechanism. The rocker bogie mechanism should climb stairs, should climb the obstacle of 20 centimeter height. So redesigning that whole part was the difficult part, and we learned that from this bot only. And the last part, which was the designing a vehicle and maintaining its center of gravity in such a position that when it climbs the elevated place, it should not fall backside. eYantra Lab provides the basic robotics knowledge, basic sensor knowledge, and how the sensor and robotics part can influence our life and how it can make our life easy. Now we are intending to do a startup. We are going to meet some army personalities, and we are going to ask them what are their requirements, what are the main actual on battlefield requirements for them, and how we can make a design a bot which we can replace soldiers on the battlefield, on the war zone.